Hello everyone, in this video we are going to deploy Orange Software Community OAM stack. This is their official repo. So in this particular deployment we are going to deploy a single node Kubernetes cluster using KubeOne, and additionally it includes a metric stack which includes your InfluxDB and Grafana to visualize your performance data, which is provided from the network function in the form of 3GPP FTP files. Additionally, there is two network functions which we will be using to test the internal working of the OAM stack. These particular network functions are provided to test your functioning of call-home, netconf call-home, which connects your external component to your SDN controller, and your O1 interface. So this is your whole this is a diagram to understand the internal working to your external component. So let's first understand how it works, then we will move to the deployment part. So in this diagram we have two major components. One is external network and the second is internal Kubernetes network. So moving from your external space, we have a couple of components. So we have an ON adapter from the OEI or any kind of simulator, and by the way, OSC also provides its own simulator for testing your internal services, which includes two NFs, one is TU and one is RU. Now moving on to the user browser. So this is a user interface, and this includes your metric stack from the OSC, which includes your InfluxDB and Grafana. Then there is an SFTP server which is deployed for a couple of minutes by your robot framework that triggers certain automated tests by your API gateway, which is this Nginx, to test your whole the working of your whole network. And you can also see in the logs that data file collector basically fetch your PM file through SFTP protocol, and this whole cycle will work. So now moving to the second most important component, which is your Kubernetes cluster. So in this network we have categorized all the components in different layers so that we can understand the functionality in a more better and categorized way. So first one is your control layer, which is one of your most important part from your OEM deployment. So in this we have the SDN controller, and along with that we have SMO own web user interface, which is open daylight based user interface where you can manage and visualize all the components and working if it's working fine or not. Then some internal components like my database for a database, and to your SDNC Call-Home to connect your external component to your internal services. Then we have your ingress layer, where you have your one and only internal gateway that connects your external network to the internal services. And then your support layer, which is again your chart museum for Helm repos and your report framework for automating certain test cases. So before moving to the data collector and analytics layer and your messaging layer, let's understand this two layers through the workflow, how your O1 context is traveling through your whole network. That way you can understand these components in a more better and categorized way. So first of all, O1 adapter or any kind of simulator sends a file ready VES event by HTTP or HTTPS, and it enters your Kubernetes cluster through this Nginx ingress controller, which is provisioned TLS certificates by another component, which is cert manager. Then it routes all the traffic to your internal services, where there is a first component from your OAM stack, which is VES collector, that's connect with your external component ON adapter or any kind of simulator, and this VES collector publishes all the raw events to your Kafka topic, or in other words TMAP layer, DMAP layer is basically an abstraction layer of Kafka. So after that, your VES mapper consume this raw event and standardize them and push it back to your Kafka messaging bus. Then it is exposes this standardized file ready events to your message router via HTTP. Then message router, once this data, when this file is available at message router, your data file collector posts this file ready event, and then it connects to the network functions, which is again your DU, RU, or CU, using some certain protocols, secure protocols, let's say your SFTP, HTTPS, and then retrieve the file and map it with your appropriate data router node. Then it publishes those files to your data router node. Data router node delivers these data to your subscribed PM mapper, which what it does basically filters your telemetry data based on certain configurations, and after that it converts them into the VES format and publish it back to your message router. And one more thing that I forgot to mention, that is your data router basically checks if the data files are basically following all the routing rules and everything or not. So this is the complete workflow where ON context or VES event is establishing your internal network, and the functioning of all the components are how these events are managed and processed. So you can also understand how, like, what components are used for what reasons. So you can read this blog. So in this blog, which is present at NGCO docs, so I've started with the basic understanding of OSC OAM and what ONAP components are used in this project. Then some internal components, internal protocols that is being used. So netconf and YANG models are used for synchronous configuration, which happens between your SDN controller and your network functions. Then your HTTP or VES event for synchronous notification to ensure interoperability between your SMO and your RAN network functions. Then I have also mentioned the GitHub repository that you can follow up to set up your own OSC OAM stack on your system. Then a snapshot of my Kubernetes cluster where I have included all the pods running in my system, and then describe them into a functional layers so that we can understand which particular pod is working what kind of functionality in your particular cluster. Then description about brief description about your all components, SDNC controller, then your dashboard, then VES collector, and your messaging layer, which is an abstraction of Kafka, and then data router architecture, and so on and so on. Then there is a bulk file processing pipeline. So in this pipeline you have certain components working side by side to carry out the whole process. So it includes data file collector, PM mapper, then VES mapper, and health check. Then for visualization, it includes your metric stack from the OSC, which includes InfluxDB and Grafana for visualization. Then there are two components, key clock and traffic, which is not included in this cluster because these two components are really needed when you deploy your SMO stack for a real scenario. So key clock is basically used for managing your creation of users or roles. An API gateway, it connects your internal component to your external services. Let's say it route all the traffic from your to your Audilex. So basically SDN controller shows any kind of data. So this traffic directs all the SDNC controller traffic to your web interface. Then again your authentication related traffic will goes to the key clock through this API gateway, which is traffic. Then again some examples of data flows where you have certain functionality and how it actually works between what components with an example. And there's one thing I want to mention, that is PNF registration. So in this I have especially taken example from the OEI. So, and I have also mentioned a payload, like what particular configuration, what particular payload went from your O1 adapter to your SMO and in what form. So this is kind of message it sends from your O1 adapter. Then that's it. So give it a read. Coming back to your deployment part. So let's start with the deployment process. So first of all, make sure you meet your hardware requirements with this particular minimum specifications. So in our deployment, we are using Ubuntu 22 for the OS, CPU 8 CPU and RAM. So in this part, we are using 12 GB RAM. And for that we are going to face certain issues which we are going to resolve that as well, but make sure you have the necessary minimum specification so that you won't find any issue like that, and if you find it, make sure you resolve it like I do in this video. So let's start with the deployment. Okay, so in this part you have to make sure you have the passwordless sudo access. So in my VM I have already the sudo access. I don't have to write the password, but if you have to write password in your particular VM, so make sure you have this particular file and add your username following by this particular message, so that you don't have to write messages each time you use sudo. And with this particular deployment is basically using your sudo commands, and if you don't give the passwordless access to it, so it will cause some certain errors. So let's move to the next part. Then after that you have to run this script. So it basically asks you for certain network settings, and for that we are going to use your our host IP for internal and external IPs, and for FQDN of the server I'm going to use the default one, but you can change it as you wish. And to resolve this particular host name, as to particularly resolve this FQDN, I'm going to add this as my local address to trick my system that this is my local network. So let's start with running this command. It asks for your VM's internal IP, so this is my default host IP. I'm going to use it as it is, so enter, and same for the external IP as well. Then it will ask you for the FQDN of the server. I'm going to use the default one, and for that to work I have to add it to my host. So in this location I have to add this line. So this basically tricks the system that if it tries to access this particular network, so it will go to this particular IP, which is again your internal network. Then after that, so your KubeOne needs to access to your SSH command. So for that we have to give it we have to start your SSH agent so that it can access your SSH to your local node. and before that we have to also generate a SSH key pair. Why that so? So first of all, we are getting this to create a local private and public key. Here you can see two keys are created, which is based on RSA. So this is a private key and this is a public key. And then we are going to start the SSH agent, which will be used by KubeOne to have an SSH access to your node. Then I'm adding a private key of the agent to your system. Then this one will be needed to authorize the key locally so that you can access this server, this particular node, through the internal networking. I will let you know, show you how I'm going to do that. So for that I will SSH. OAM is the username of this system, then the internal IP, which is this one, then enter. So why I have added this one, basically, so if you don't add the public key to your authorized key, so I won't be able to access SSH into my own local system. So for that I have to add this RSA public key to my authorized keys. Then I log out to this connection. Now the next step will be deploying your Kubernetes cluster, which will have to run this command. Get back to your this place, then run this command. So it will take a while. And there's one more thing, if it fails at certain point with this message, basically it says, like in this message you can see it fails due to fail to contact your webhook, which is a certain cert manager. So for that you have to first check if your nodes and pods are up for the certificate manager. So you can do this with these commands and wait until it gets up, and once it is up you can run this command again and it will definitely work for your system. So let's move to your deployment again. So fortunately we did not meet any error, so this is fine. So let's move to the next step of this process. Okay, so we have to override certain configurations, which is this one. So in this we have to add two lines. One is this one, because what happens with the Bitnami images, so all the old images that Bitnami no longer support or continues, it moves those images to Bitnami legacy. So we are going to update those images on the global configurations and the global section in this file. First one is this and second one is under MariaDB Galera. Okay, so here Now the configuration is done. Let's deploy the application stack of SMO. So this error is kind of expected because we are currently using low resources. So let's see how to debug this and verify if it pass all the test cases. So first of all, we are going to check the logs if all the pods are running up with healthy status. So now all pods are running and are in healthy status. So let's check the logs of data file collectors to see if it is stuck at fetching the polling the status from the message router, and it is able to connect and communicate with the message router successfully without any issue. So for that, okay, okay, so it is not showing error regarding fetching the files from the Kafka or the message router. So it is giving issue, so it is an error from the HTTP server. So it did not find the HTTP server and not able to fetch the files. That's why it may be some issue in the execution or maybe the starting of these pods. So for that we can again run this test cases manually so that we can verify if it is working correctful and showing healthy status right now. So what happens sometimes, so there is some issue with deployment of SFTP server which cause error in the data file collector to fetch the files from this SFTP server. But now our all pods are up, so we can able to fetch those files from the SFTP server, and most probably this time it will pass all the test cases. Now let's wait and verify it. Okay, now you can see that it has passed the first test case, and following with the test cases, it has passed all the test suits. So now we have successfully deployed the SMO stack with all test cases has been passed. So now let's move to the, so here I've also mentioned one of the issue, like if you see in the data file collector logs that it shows some issue with connecting with the Kafka. So for that you have to restart your message router pod. So what happens sometimes when the pod restart, what happens basically, so message router is a lightweight application, whereas Kafka is a heavyweight. So what happens sometimes, message router takes much less time than Kafka, so it shows some issue and fetching the details from the message router. So in order to correctly fetch the details, pose all the events, it has to be restarted and then check the logs of data file collector again, and if it shows no error regarding the Kafka or message router, then it is working fine, and looking for fetching the file from the SFTP server, which we have to confirm through running this script. Then in order to access your SDNC web interface, first of all, this is on Kubernetes cluster, get services in Kubernetes cluster with type of cluster IP for everything. So for that we have to port forward to the local system, and we are going to use 8181 on our local system, and using 8080 from their services, which is, you can confirm it here. So it is exposing all the services, all the services on 8080 port. So we are going to expose this internal Kubernetes pod interface to local system 8181 interface, port. Now let's verify it. We have to go to this particular interface URL, and here we have to paste the VM IP. Let's first confirm the VM IP. Okay, this one is VM IP. So if okay, so there is a cache in my browser, so it automatically takes your username and password. But if it asks for username and password, then use these values, admin and admin, and you will be able to successfully log in to your system. Now there is no node connected to your system, and other sections will also be empty. So for that, to verify, just deploy your matrix stack and your test network functions. Let's stop this for now. So to deploy your matrix stack, and in this matrix stack you will get a PM microservice which will consume your PM data, performance management data from Kafka, and write it your InfluxDB, and then you can visualize this through Grafana. It has been successfully deployed. So again, for Grafana as well, so you can check the services. So here Grafana and InfluxDB services has been up, and these are also using cluster IP, which is an internal IP, and you cannot access those particular port. So in order to access those particular interfaces of Grafana and InfluxDB, we have to first port forward these particular services on local system on a certain port number. So let's post forwarding this ONAP Grafana on this particular port 8082. And for that we are going to use this one. On this URL we are going to use VMIP, which is this. Okay, so it is asking for username and password, and for that use these values: admin for username and admin 1234 exclamation mark. So now we are successfully logged into Grafana. Similarly, we have to port forward your InfluxDB services to your local system, and for that you have to use this particular command. Now for that use this URL with VMIP. So it is asking for username and password. Use this one, username and password. Now we have successfully logged into Grafana and InfluxDB dashboard. Now let's stop this for now and deploy your test network functions. Now our network functions has also been deployed. So these are particular logs with it, and we are currently deployed 3 particular pods. So you can also check it using get pods. So here you can see there are 3 pods, and one is for one ODU and 2 is for ORU on the network interface. And let's check your SDNC web interface whether these nodes are actually shows connected on their interface or not. So for that we have to first port forward this particular service and reload this again. Okay, now you can see that and verify that we have successfully connected these 3 nodes from your test network functions and shown connected status in your ONAP dashboard. Now let's stop this. So in order to remove that you have to use this command. There is no make and deploy test network functions make command for this, so you have to manually use this script to undeploy your network functions. Then in order to get your deployment details, run this command. So here you can get your Grafana dashboard credentials, SMO Audulux, web interface and username and password, and your VES collector URL. So there's a further section for how you can expose your VES collector of your OEM stack from the Kubernetes cluster for ONAP adapter. So for that we have to follow a number of steps, but now for now in this deployment we are going to be limited to test it with the network functions. In the next video, we are going to deploy one adapter and going to follow this particular directory, and what configuration we need to update on the ONAP adapter to connect it with the OSC OAM. So we are going to cover everything on the next video. So have a good day. Bye.